Hello guys and welcome back to LeetLogics. This is the parallel course 3 and it is a LeetCode hard, but it will not be if you watch the video till the end. The number for this is 2050. So let's come to the question. So in this problem you are given with a set of courses labeled from 1 to n, each with a specific time duration to complete given in months, and we are provided with a set of prerequisite relationship among these courses in the form of 2D array where each entry is in the form of like previous course and next course, where the previous course must be completed before the start of the next course. This is a prerequisite. The goal is to determine the minimum number of months needed to complete all the courses, such that following the condition that we may start taking a course anytime if prerequisites are met, and also we are allowed to take any number of courses at the same time. So in this problem, it is designed in such a way that it is possible to complete every course, which means the graph of the course prerequisite forms a directed acyclic graph. So it is given in the question, ensuring that there is no circular dependencies in the courses. So the intuition is like to solve this, we may need to complete the minimum numbers of months required to complete all the courses while all the prerequisites are met, and the possibility of taking multiple courses at the same time, we'll consider that also. This is typically done by creating a directed graph and performing topological sorts to determine the order in which the courses should be taken, and like considering the prerequisites. But we'll follow a more better approach. Like you can understand, it will be very easy to understand for you. So let's jump to the solution. So in this solution, we will create a directed acyclic graph first. So for that, we have created a function toGraph, and we have also declared some global variables. I will tell you why do we need them and where do we need them. So first of all, we have created a function toGraph. This is used to convert the edges into the graph. The graph directed acyclic graph of the courses and the prerequisite. So first of all, we define the incoming array and the outgoing array, and in this we keep the count of incoming edges and the outgoing edges for each node. So you can see we have iterated through all the edges. We calculate the outgoing edges for a particular node, we calculate the incoming edges of a particular node, and then we need to calculate the number of nodes from which we can start. So we can start from the courses which do not have any incoming edges. That means they do not have any prerequisites. So we can start with that courses. So first of all, we'll iterate through the incoming array. We'll check how many of them have incoming edges as 0. We'll increment the start counter, and then we'll initialize and the start nodes which we have taken initially with the number of int with the size of number of starting nodes. And we have also kept a counter here sni and I, where we iterate through the start nodes, and keep the we initialize the start node with the help of the information which we have here. Then what we'll do, then we need to create the graph from the given information like which we have calculated. So we'll try to create the graph. Here you can see for int I equal to 0, I less than n, we are creating a graph of I such that there is a new, for each graph of I we have a outgoing number of edges, and in the outgoing edges we store the outgoing edges as well. This is not a difficult thing to understand. If you are still unclear here, let me just make you understand again. So what we do is that we create a graph structure based on provided prerequisites. We have taken a 2D array where the row represents a course and the elements in the row are the courses that depend on the corresponding course. So the graph is in this form. For example, like if course 1 is a prerequisite of course 3, then the graph of 1 and 0 will be 3, because we need to complete the course 1 before completing the course 3. So that's why the graph is created in that form. It will help us to calculate the time in the further board. You can see then we have a calculate function. So this calculate function, what it does is that it is used to return the minimum time which will be required to complete the course, such that all its prerequisites are met. So in this, first of all, we check if we have the answer already stored for a particular node. If we have already calculated the time for a particular node, then we simply return the time. Otherwise, we take a worst prerequisite. This is used to hold the maximum of the time among all the childs which we are going to uh, calculate. Then, while visiting a node, we are marking it as visited, because there may be uh, multiple same values in different rows of the graph, because there can be multiple prerequisites. So we need to make sure that a single node is calculated only once, otherwise it may give a wrong value. That's why we have taken the visited here. So the visited of node we have taken as true. Then we have iterated through the child nodes in the graph, and if the visited of child is not there, we iteratively calculate the. Then we simply calculate the prerequisite by uh, calling the calculate function recursively. And once we have calculated for each, we mark the visited as false, and we simply store the answer of node, that the which is the worst prerequisite, along with the time required for the completion of course. This we store in the answer and simply return this. So this was the calculate function used to calculate the time for a course along with prerequisites. Then we have the function which was given to us by as a driver function. So first of all, in this we'll follow what we have done in the first part. We'll convert the edges and relationship into graph. So we have converted into the graph, and we'll try to make the time as a global. This we have made try to make as a global variable, because we need to access it multiple times in different functions. So that's why we have taken it as global instead of passing one by one to another functions. Then we have the answer. This you can call as a if you dp to store the answer, but it is not actually a dp. What it does is that it stores the time for individual courses, the time required for individual courses. And then we have that visited array. So we initialize the visited as well here. And then we have the longest. So this longest is a variable used to keep the track of longest time which is required by any of the starting course. So any of the courses which have the largest time, it will take that. So longest is used to store the largest of all the times. So we iterate through all the starting nodes. We add it into the we calculate the time required for each node, and then we store the maximum out of them and simply return the longest, because in our calculate function we have already considered the prerequisites. So we are sure that the prerequisite will be met and the courses are completed after that only. And also the graph, the courses which do not have any prerequisites, we can start the number of courses at the same time. So that is not a problem for us. So if we will be taking the maximum months, the the courses with the lesser months will already be completed in that course of time. So this was my solution. Let me just run it for you. I have already submitted once, like for you. You can see it runs fine. Beats almost 100% in time and 65% in space. So let's come to the time complexity now. So the time complexity for this question is this solution is big O of n, where n is the number of courses we visit, uh, each course exactly one, and the space complexity is O of n, that is required in the visited array and the incoming edges and the answer array. So that is also big O of n, because we are taking a linear array to store this. So this was my solution for parallel courses 3. I hope you like the video. Please do like the video, share it with your friends, subscribe to my channel. I need your support, guys. So we need to complete our 100 subscriber very fast. So please do subscribe. Thank you for watching the video. Have a nice day.